To understand how a bug grows to the size of a mountain bike, you have to stop looking at the ground and start looking at the air. Today, every breath you take is about 21% oxygen. It's enough for us, and it's enough for the tiny ants at your feet. But 300 million years ago, the world was huffing pure nitrous. Atmospheric oxygen levels had skyrocketed to a staggering 35%. The planet was essentially a hyperbaric chamber, and for insects, this was the ultimate biological cheat code. See, insects don't have lungs. They don't have a heart-pumping, oxygen-rich blood around their bodies. Instead, they breathe through tiny holes in their sides called spiracles, which lead into a network of tubes called tracheae. In our world, oxygen can only travel a few millimeters into those tubes before it peters out, limiting how thick an insect's body can get. But in the Carboniferous, that super-oxygenated air acted like a high-pressure hose. It pushed life-giving gas deeper into the muscle tissue than ever before. This secret fuel didn't just allow insects to get big, it forced them to. In this atmosphere, being small was a waste of potential. To be a giant was simply to breathe. Step back into the Carboniferous, and you wouldn't recognize the trees. There are no oaks, no pines, and not a single flower in sight. Instead, you're standing in a coal forest, a sprawling emerald cathedral of giants. Towering 100 feet above the mud are the lepidodendrons. We call them scale trees because their bark isn't rough like a modern maple. It's covered in diamond-shaped scars, making the trunks look like the skin of a massive green reptile. These weren't woody trees as we know them today. They were more like giant, vertical sticks of celery, growing at a blistering speed in a world that never stopped for winter. Below them, thickets of calamites, prehistoric horsetails, rise from the black water like 30-foot bamboo. Because the earth was tilted differently and the atmosphere was so thick, there were no seasons, no autumn, no frost. Just a relentless, humid 30 degrees Celsius day after day for millions of years. The air is thick with the scent of rotting vegetation and floating spores. In this hothouse, the silence is only broken by the heavy thud of a falling branch, matter that will eventually be crushed by time into the very coal we burn today. This wasn't just a forest, it was a giant, sun-powered carbon factory building the world of tomorrow, one massive leaf at a time. On the forest floor, something massive is moving through the ferns. It sounds like a dozen soldiers marching in rhythm. This is Arthropleura, the undisputed heavyweight champion of the invertebrate world. Stretching nearly 9 feet long and weighing up to 100 pounds, this isn't just a bug, it's a car-sized tank with dozens of legs. It is, quite simply, the largest land invertebrate to ever walk the earth. A hungry Proterogurinus, a primitive crocodile-like amphibian, sees a mountain of meat and lunges, but its teeth just slide off. Arthropleura's body is encased in thick, leathery, chitinous plates. In a world of sharp teeth and swamp predators, this giant is practically untouchable. It doesn't need to run, it just keeps moving, indifferent to the world around it. But here's the most terrifying part. Despite its monster movie appearance, Arthropleura wasn't a hunter. Fossilized gut contents suggest this titan was likely a vegetarian, a peaceful giant that spent its days bulldozing through rotting logs and giant ferns. It was the elephant of the Carboniferous, too big to be bothered and too armored to die. While giants ruled the ground, the sky belonged to a king with no rivals. Look up, and you'd see a shadow the size of a hawk circling the canopy. This is Meganeura. With a wingspan reaching 2.5 feet, this isn't just a dragonfly, it's a griffinfly. In the Carboniferous, birds, bats, and pterosaurs don't exist yet. For millions of years, Meganeura was the most advanced flying machine on the planet, ruling the air with zero competition. Its greatest weapon? Vision. Those massive wraparound compound eyes gave it a nearly 360-degree view of the world. It could track the slightest twitch of a lizard or the flutter of a smaller insect from dozens of yards away. To a Meganeura, the world moves in slow motion. It is an aerial interceptor, capable of hovering, flying backwards, and diving at speeds that would leave modern insects in the dust. It strikes with terrifying precision, using its spiny legs like a basket to scoop prey right out of the sky. It doesn't just eat, it dominates. In a world of giants, Meganeura was the one thing you never wanted to see between you and the sun. Most of us are used to scorpions being small enough to fit in the palm of a hand. But in the oxygen-heavy shadows of the Carboniferous, nature took that design and scaled it up to the size of a family pet. Meet Pulmonoscorpius. At nearly 28 inches long, this was a literal giant. Imagine a scorpion with the weight and presence of a domestic cat or a small dog, scuttling through the undergrowth. This wasn't just a scavenger, it was a highly specialized terrestrial stalker. Its name actually means breathing scorpion. Unlike its ancestors who lived in the water, Pulmonoscorpius had evolved advanced book lungs to pull that 35% oxygen directly from the air. This allowed it to maintain a high-energy lifestyle, prowling the forest floor for small amphibians and other oversized invertebrates. It moved with a terrifying mechanical grace. With two thick, powerful pincers to pin down struggling prey and a venomous stinger the size of a hunting knife, it was the ultimate nightmare of the forest floor. In a world of giants, Pulmonoscorpius proved that sometimes the most successful hunters aren't the biggest tanks, but the ones with the sharpest sting. If you thought a dragonfly the size of a hawk was strange, meet the insect that looks like it flew straight out of a sci-fi horror film. This is Mazothyros. At first glance, it looks like it has too many parts. While most insects have 4 wings, Mazothyros belonged to a bizarre, extinct group that appeared to have 6. In addition to its main wings, it sported 2 smaller wing-like lobes near its head. Whether these were used for stability or just for show, they gave this creature a silhouette unlike anything alive today. But its wings weren't its most lethal feature. Look closer at the head, and you'll see a long, needle-sharp proboscis. Mazothyros was a pierce and sucker. It used that organic syringe to tap into the high-pressure sap of giant-scale trees, drinking the forest's lifeblood. But some scientists suspect it didn't stop at plants. Those sharp mouthparts may have been used to pierce the hide of other animals, making it a giant, 6-winged vampire of the Carboniferous. It represents a lost branch of the evolutionary tree, a Paleodictyopteran that mastered flight and specialized feeding long before the first dinosaur ever hatched. In the world of giant bugs, Mazothyros was the weirdest of them all. For millions of years, that 35% oxygen was a gift, the secret fuel that built an empire of giants. But in nature, every gift comes with a price. And in the Carboniferous, that price was fire. Oxygen isn't just for breathing, it's an accelerant. In an atmosphere this concentrated, the world became a chemical tinderbox. Even in a humid, steaming rainforest, the air itself was primed to explode. A single lightning strike didn't just start a fire, it triggered a superfire. Because the air was so reactive, wet moss and damp wood burned with the intensity of dry gasoline. Fossil records show massive layers of charcoal from this era, evidence of global firestorms that could jump across rivers and incinerate entire ecosystems in a heartbeat. The very air that allowed these giants to grow was now their greatest curse. The thick, heavy atmosphere carried the heat further and faster than it does today. For the titans of the Carboniferous, there was no place to hide from a world that had literally caught fire. The firestorms were just the beginning. The world was changing, and for the first time in millions of years, the clock was running out for the giants. As the Carboniferous drew to a close, the planet's climate shifted. The endless summer ended as the earth cooled and the great swamps began to dry up. But the real killer was invisible. The oxygen levels, the very lifeblood of this era, began to plummet. As the air thinned toward the 21% we breathe today, the giant insects hit a biological wall. Their massive bodies, once fueled by high-pressure oxygen, were now too large for the atmosphere to support. They weren't hunted into extinction. They were suffocated by a world that had literally outgrown them. Their tracheal systems could no longer push enough air into their massive tissues. The secret fuel was gone. The titans fell, but life didn't end. The survivors were the small, the efficient, and the adaptable, the ancestors of the bugs we know today. The age of giants was over, buried under layers of sediment to become the coal that fuels our modern world. They left behind a legacy of power, a reminder of a time when the earth belonged to the small, made massive. The giants didn't just vanish into history, they were swallowed by it. As the great rainforests collapsed, billions of tons of wood and insect chitin were buried in the mud. Because there were no bacteria or fungi yet evolved to break down all that organic matter, it didn't rot. It sat there, compressed by the weight of millions of years, transforming into deep, black veins of energy. This is why we call it the Carboniferous period. When we burn coal today to light our homes or power our cities, we are literally burning the remains of that alien world. The heat in your fireplace is the trapped sunlight of a forest that died 300 million years ago. But their most beautiful legacy is still alive. The next time you see a dragonfly zip across a pond, look closer. Its wings still have those same intricate veins. Its eyes still see the world in a 360-degree blur of motion. It is a perfect miniature blueprint of a king that once ruled the sky with a 3-foot wingspan. The giants are gone, but their spirit is still in the air. We're just living in a world that's finally small enough to handle them.